Good morning, guys. Okay, so today we will be talking about the last chapter for midterm 2, which is chapter 7. And it will be highly related to what you have done so far for your project, but we're just talking about a bit more on the front end of the application design. So up until now, we have not yet touched upon the concept of internet so far. Everything we're talking about, just assuming everything happens on the local machine. Even though on NoSQL, we kind of mentioned a little bit about distributed computing. But in this chapter, we are going to mostly focus on the idea of internet when we talk about database application. All right? So what we will be covering today will be these topics. We'll first start out talking about the internet concept, which is really simple. An internet concept, along with communication protocol, which is HTTP, will be basically the most simple idea you have learned in computer networks. So who have taken computer networks? Oh, okay. Okay, then I'll put more emphasis on it then. I assume everyone had taken it, all right. So that will be, we will talk about how the request is sent from the user when it is communicating with the server and how things are sent back, right? So for what we're talking about today will not be so closely related to what we have learned so far in terms of database modeling on the first glance of it, but then you can think of it why we want to talk about this, because it's all about displaying things on the internet level. And after talking the first 2 bullet points, which is highly related to computer networks, some of you have taken the course before, we will talk about web data format. So these are the things I would assume most of you have a little bit of experience on. So who have written things on HTML before? Quite a lot of you, right? So who have more of a basic understanding of the tags of HTML? So when you guys write it, you write it from the code instead of writing it from maybe a web page editor? I assume, okay. And how about who has any experience in XML? A few of you. All right, cool. How about JSON? Good. Okay, more of you. Okay, so we are going to talk about the 3 data formats. So one thing to note is that when you read the textbook, when you want to understand a bit more, actually the textbook didn't mention anything about JSON because it's more of a newer thing. It was created in 2004, but I would just include it anyway because nowadays JSON actually largely replaced XML. Okay, and then we will talk about markup versus markdown. Who have heard of markdown before? Quite a lot of you. It's like the fixed group of people who kept hearing the same thing. So for markdown, I will talk about it a little bit. It was not mentioned in the textbook either, but I think it's worth noting because it's more of what people are using right now in different kind of application, okay? So I will have a comparison of it versus markup, but before we get in there, just to remember, actually markdown is not the opposite of markup. Markdown is one kind of markup. Okay? It's kind of tricky. When I first heard of it, I was confused too, but actually it's totally not how it looks like. Okay, then we will talk about DTD, which is actually the document type definition, okay, at the very end of the lecture. So these are the things we're going to talk about. Let me see. Oh, and also next time, maybe next lecture or on Friday, I'll quickly go through one of the techniques you can use to scrape data from the web, because I know some of you have already done it. You have collected data from the internet for your project, but some of you haven't because some of you are struggling with how we can collect large amounts of data to use it in your database. Maybe for now you're just manually typing in some of the data entry. So maybe on Wednesday or Friday I will talk about one of the tools you can use. Okay? So you don't have to get hands-on, you can just see me doing it, but I will show you why it's powerful. Okay? So what we will be talking about will basically, for example, we search for Amazon, maybe we search for a pot in the kitchen. And you can just basically write an automatic script for collecting all of the product information of that. Okay? So just to give you a little bit of preview of what's going to happen. All right, let's get started from the first 2 bullet points in terms of the computer network's idea. So the first concept we want to talk about today will be called Uniform Resource Identifiers, which commonly we call the URI. So quite often you heard of URL instead of URI. Okay? So URI, what it means is actually the uniform naming scheme to identify resources on the internet. And the resource itself can be different kinds of media. It can be the web pages, it can be the images, or a downloadable file, which means it can be video, anything, or it can even be the email address you're sending to or you're receiving things from. So just any kind of resources that need any kind of communication. So URI in general has 3 parts. Okay, the first part we call the protocol to access the resource. So one of the most common example of it will be HTTP. Okay, so then by giving you HTTP, you know what it actually means. Okay, so that's the first part of URI. So other examples of URI, you can imagine, maybe you know what normally happens when we have kind of a link. So what happens before the colon // So we can also have FTP, right? Or another type would be, do you guys know mail to?
SMTP.
Huh?
SMTP.
TP. Yeah, that would be one as well. Okay. Or HTTPS. Okay, so different kinds of protocols. So the other one I said, the mail to, if we just put MAILTO, it means when you click the link, it will open like the email software where you directly send email to the address. Okay, so that's one of them as well. But all you have to know when you think of a protocol to access a resource, just think of HTTP. Okay. Then the second part of URI is the name of the host computer. So here we have an example of just the website of the department. Okay, so that's the host name of it. And the third part of URI will be the path name of the resource. So for example, if we provide this path name all the way to the resource, where the resource is here, index.html, that's the web page, right? So that's document, then that would be the path name of the resource. So earlier I said quite often you will hear URL instead of URI. So URL actually stands for Universal Resource Locator. And it's a subset of URI, okay? But we won't really get into too much detail of what's the difference between them because actually a lot of times people get confused and just use them interchangeably. Because when you look at this, you will actually think it can be a URL as well, right? So when you go back, you can look up URL versus URI when you open Wiki. It's actually like some people will say it's an overlap, some people say URL is a subset of URI. So we're not really distinguishing the difference in the lecture, okay? So we might use it just interchangeably. So here we say protocol to access the resource. So let's talk about protocols. We actually have quite a few different kind of communication protocol. So when we talk about communication protocol, we are saying it is a set of standards that defines the structure of messages between 2 communicating parties so that they can understand each other's messages. So as you can imagine, when we have 2 parties trying to communicate with each other, they might have different kinds of languages that they use. So you needed some kind of protocol so that they can map it, port it onto the protocol. So some examples here, for example, TCP or IP. We won't get into much of here because it's a very computer network thing. But another example will be HTTP. Okay. So HTTP will be one of types of communication protocol. So what actually is HTTP? So I think some of you already know what FTP is, right? FTP, you can, for example, when we are designing a website for this course, we can open like a software called FileZilla, or you can directly upload files from the command line through the FTP address, okay? And how about HTTP? So HTTP actually stands for Hypertext Transfer Protocol, okay? So you can think of it as more like a client-server protocol, okay? So two parties on each side of HTTP will not be equivalent. So it's more like a server serving the client kind of thing. Okay, so that's what HTTP definition is. So let's think about what actually happens when you click on the web page in terms of having the HTTP protocol to help you. So when you click on the web page, whatever link you click, okay, let's say today you click on a link that goes to our course website, then the first thing that will happen is the client, which is the web browser you're using, okay, doesn't matter, Chrome, Firefox, maybe not IE, I guess. So the web browser will send an HTTP request message. So a request message will be sent to the server whenever you click on the link. Okay. Later I'll show you how the request message will look like. So assume the server receives the request message without any error. Then the server will reply to the client, which is a web browser, with HTTP response message. Okay. So after, let's say there's no error either, so now we are just assuming it's a really smooth procedure, okay, no error happens. So after the HTTP response messages was received by the client, which is your web browser, it will display the things, render the things on your browser so that you can see it in the window. Then the client, you can make a new request again. Okay. So what are we actually talking about here? What do we mean by the request message and the response message? So here will be an example. I'll show you first how they compare, what it looks like when we compare them, and then go through each line what they do. So here will be a snippet of how the client request message looks like and the server's response message looks like when we use the HTTP protocol. So if we just slightly observe the left side, you can see we want to get a certain web page, okay? And you talk about which browser you're using, and you talk about what kind of data format you want. Okay? And on the right-hand side, it will give you the status of the response, and the time, and what server is generating the results, and the contents. Okay? So let's go through it line by line. Let's start from the request message sent by the client first. Okay? So here will be an example of the request message. Okay? So I broke them down into 3 parts. The first part will be the request line. Okay? And the first part is the type of the client, and the third part will be what types of files will the client accept. So actually here you can't really see it, but whenever you send a request or you receive a response, the way they identify it's the end of such message is actually by using like an empty line. Okay? You could just say, actually at the very end is the empty line. So it knows the message ends. So let's see what are included in the request line. So actually in the request line, you can look at it into 3 parts. The get and the path and the version of HTTP. So let's start with get. Okay. So get is actually an HTTP method field. Who has designed, let me see, who has designed a web page that includes a form, and when the people fill it out, you can send that to the email of the owners of the website who have designed anything like that before. Okay, so if you design like a form, okay, on the web page, and you have different kinds of fields for the user to fill out, whenever the user finishes filling out, let's say you want the form to be sent to the website owner's email, then we will have another HTTP method will be used, but that's what we call the post. Okay, so here we can either use get or post. For getting, we are saying we want to receive this web page. For posting, it means we want to send to a certain address. Okay, so that's what actually happens whenever you design such form and then the people fill it out and click submit. Okay, so that's what the post will do. So for request line, we can have 2 kinds of HTTP methods. One is get or post. Okay, but quite often we just use get because that's what happens in the browser. And for the second field, it's actually the URI field. So as we said earlier, here we kind of just make it really simple, just say it's in the root. But this is not a very clever way of saying it, because you don't know on the whole internet who's the root, okay? But here we're just using an example. And earlier, as we said, URI, we have 3 parts, right? We started out saying what is the protocol, and then we say what is the domain name and the path to the resource. Okay? So here, we actually omit the protocol because we don't have to use it, we just know it's through HTTP. Okay, so the second part will be the URI, or we say URL because we're not trying to distinguish. And the third part will be the HTTP version. And here we won't get into too much of it. Basically, we have HTTP 1.0, we have HTTP 1.1. Okay, but the most commonly used now is 1.0. Okay, so we just put it there. All right. So that would be the first line, the request line. You are saying, I want to get a resource identified by this URI via this kind of HTTP version. Okay. So the second line, you're just basically talking about what type of client we are using. So whenever we talk about the client in this scenario, we're just basically saying what kind of browser we're using. Okay. So you can also change this to Mozilla or any kind of Safari, any kind of browser. Okay. So that's the second line. We want to use type of client. And then the third line, we will basically just state what kind of files that we want to accept. So here we only have text, image, text and image. Okay? So if you are trying to receive any kind of videos through this request, it won't work. Okay? It won't go through. Okay? So just the other kind of resource will go through. So that's for the request message. How about the response message? So here will be the response message. Actually, the response message can be broken down into 3 big parts. The first part will be the status line, okay? And so the status line is just basically saying whether the response is okay. Right? So we have different kinds of status code. You can see the first, in the status line, for the first part, we're just saying what version this is, like the earlier one. And for the second part, you see the C3 digit. So I think quite often you will see, if it's error, you can see 404 or 400. Okay? So those are where it's from. Okay? And different kind of browser renders this information differently. It's just basically because they receive the code, and for Chrome, they have one way of displaying it. For Mozilla, they have another way. Okay, the third part is just saying if it's okay. Okay, it's okay, then it's just basically, okay, this is successful. And the second big part of the whole response message will be the whole thing right here. So right here, a lot of things are optional. You can mention it, you can omit it. But for the second part, we say it's the header. So for the header, it will include the date and the server type. So here the server type is Apache, and we say it's Linux. And you can talk about what's the length of the content and what's the type of the content. Okay. But so far, we haven't not gotten into the body of it. Okay, so for the header, you can just include different kind of information. Another example that is not here, but you can also include is the last modification time. Okay, so quite often you will see last modified and then put the update time. All right, so that's the second part. And the third part of the whole response message was just to basically say that's the body of it. Okay. So here, some of you might already notice that's the HTML code that you might be familiar with. So for the body part, it just contains the actual object. Okay, so a lot of times, maybe it's not text, but it can still be rendered into different kinds of textual message, so it can still contain it. But quite often, it would just be either HTML or XML, that kind of thing, to help you render the document. So this will just basically be how it looks like when the client requests the web page and the server responds the web page back to the client. So the browser, after receiving this, it can just render things based on the content right here. Okay. So a little bit of fact about HTTP. So whenever we talk about HTTP, now you can use website to do so many things, right? For example, you are shopping on Amazon, and maybe without even logging in, you can remember what you have put into the shopping cart, right? Because the browser helps you to keep track of it. But actually, if you only talk about the HTTP itself, we call HTTP the stateless protocol. So by stateless, we are saying actually it doesn't remember anything. So that means every time when you send a request and you get the response, that's it. So for the next request the client makes, it doesn't care about what's the last response, last request it makes. All right? So that's when we only slowly talking about HTTP itself. So HTTP doesn't have any session, okay, just doesn't remember it. And every message is completely self-contained. Okay? So as you can see earlier, we make a request and we see the web page. We make another request, we see another web page. But they are totally independent with each other. So no previous interaction is remembered by the protocol. So this actually creates a trade-off between the ease of implementation and ease of application development. So some people might think this is easier to design, but some people might think this is not. Okay, so when HTTP was first designed, they decided to make it stateless. So there are some trade-offs of it. So as I said earlier, for example, shopping cart is a highly required function in a lot of different applications. So for these kind of functionality, we have to build on top of HTTP. So here is just an example. So we say any state information, for example, shopping cart or user login information, or a lot of times you go to browse Amazon again and it will remember what you have viewed before. Okay. So these are all remembered, then they need to be encoded in every HTTP request and response, or other kind of methods that we can use. So I'm just sure a lot of you already know what can be used to achieve this. So what do you think would be one of the most popular methods? What is it? What?
Post method I use.
Post method. Or another more commonly known name?
JSON ID.
Easy, like a very easy name of it. Like, for example, sometimes you go to a website where the dialog will pop out saying, if you turn this on.
Cookies.
Yeah, cookie. Okay, it's just cookie. If you turn this on, then it gives you a better user experience. Sometimes they would say this, right? So cookie is the most famous way of handling the fact that HTTP is stateless. Okay, so cookie can help. So sometimes you can turn it off, right? On the browser, you can say, I don't want cookies, because you might be doing something sneaky and you don't want it to remember. But if you have cookies on, then it will remember it. Okay, so basically, so this is one of the really annoying features for me, because if I go to browse some shopping sites, when things get really irrational, you just keep going to different kind of shoes, different kind of products, right? And then you realize, no, I shouldn't buy them, and you will click them all off. And the next time you go to another website, for example, if I'm looking up dictionary, there will be an ad showing the exact same shoes you have seen before, and that's not my cookies. Okay, it's a really dangerous thing. Or another way of solving this problem will be dynamically generate unique URLs at the server. So one example will be, let me see. I'm not certain whether this is true, but I've seen it before and I think might be true. For example, when you go to Google and you search the queries, keep typing in different kind of queries sequentially, and you will actually see your previous queries being embedded into the URLs. You'll keep concatenating them. I think it's still designed this way now. Or you can go to YouTube, and when you go to another video, maybe recommended by the previous video, it will also show where it is from, okay, on the URL. So that's another way. So they can embed, for example, the user's path in the URL. Even though you have a way shorter path to it, directly to the video, you can still embed, maybe you are going through this and that to that video. Okay? So that would just be what basically we want to talk about for HTTP. There's so much more that we can learn about HTTP, but we won't get too much into it because this is a database course. Okay, but we just want to show you what are the basic concepts you can kind of try to understand in a few slides. Okay. So the next big topic that we will talk about today and also next time will be the data formats that people use on the web. So what do we mean by data formats? So there are 3 data formats that we want to talk about. In the parentheses, you just need to fill out what they stand for, what the short names of them are. And I think they're very simple. So for example, the first one, hypertext markup language. HTML, yes. How about the second one? Extensible
XML.
XML. Yes. And the third one, JavaScript object notation is JSON. Right? Okay. So these are the three data formats we want to talk about. So I'm sure a lot of you are really familiar with these, but just sit back, relax, and we will kind of review it again. So for HTML, it's the presentation language for the internet, the most basic one. Okay. I don't remember when XML was really introduced, but when I first started learning to design a web page, it was when I was primary school, so that was, I think, 10 years old. Okay, so that's 15 years ago. When I first started it, I remember I bought this book of HTML, and I was trying to learn it, but I was so young, and I bought this like this thick, and I only went through like not even the first chapter. It was just too hard for an elementary school kid. So I gave it up. But now when I looked at it, it's actually so simple, you don't even need a book to understand it. Okay, HTML is really simple, which I'll show you later. Then we have XML. So it's actually trying to complement a lot of drawbacks of HTML. So XML, we say it's a self-describing hierarchical data model. You'll see later why it's hierarchical. Okay, the third type we want to talk about is JSON. So it uses human-readable text to transmit data largely. It has largely replaced XML. So here, even though JSON, I think JSON is the only data format that keeps emphasizing themselves as being human-readable, but when you actually read HTML and XML, they're still pretty human-readable. Okay, so but that's just what JSON sells themselves as. So when you try to see it, for us, every programming language we look at it, it can be human readable. But maybe for other people that doesn't have any coding experience, maybe JSON looks more like documents, just like we saw before when we talked about MongoDB, right? This kind of nested key value kind of format. It is slightly more human readable. Okay, so let's start. We will talk about these data formats one by one. And so as I said before, when you go to look at textbook in chapter 7, they actually don't include JSON. Okay, so the JSON is just included in this lecture. So let's start from HTML. So HTML, it is a type of markup language. Why do we say it's markup? So it is markup in a sense that it works by augmenting regular text with marks that hold special meaning for a web browser. Okay, so here note that it holds special meaning for a web browser. So basically it's saying in the tag, it's telling the web browser how to render things. Okay? Because the biggest task of a web browser is to take the information and render it for you, show it, display it on a window. So it's telling the web browser how it should look like. Okay, not telling the user, telling the web browser. So the basic format of HTML, you always have tags. Everything is in tags. So we will have this, we call it the start tag and end tag. So basically just start tag with different kinds of elements in there, right? So we start it and we put contents in there, and then we end the tag with / same name. Okay. So quite a lot of common tags we have will be, for example, the whole HTML document start with HTML tag, okay, and finally ends with / HTML tag. And you can put title in your HTML document as well, and title means what you will see when you open the browser. It has like the name of the web page, right, on the very top of it, not on the web page itself, but on the very top rendered by the browser. That's determined by the title. And we can also have, for example, UL, which stands for on order list. So that's like the bullet points. Okay, starting by an on order list, and then you can put LI for each bullet point entry. Okay, so these are just some of the examples for HTML. Nothing fancy of it. So here we can try to see an example of HTML. Okay, so they are pretty tiny, but okay. So as you can see, the HTML starts with an HTML tag. So here is actually all the way continue there. Okay, start with an HTML tag and finishes with a / HTML. And as a lot of you might already know, for HTML we have the head part. Okay, so in this example we don't include anything in the head part. Okay, just start head and then finish with a backslash head. So quite often for the head part, really similar to the response message by the HTTP protocol, it just contains a lot of different information. For example, earlier, the title, we talked about the title tag can be included in the header, or in the header you can include different kind of style sheet for your web page. Okay, so they all happen in the header. And the second part would be the body itself. The body is basically what you see, okay, on the web page, the contents of it. So earlier you see when we return the content from the response message, that includes the body. So body, we can, for example, for H1, it means the first header for the document, right? You render like the biggest text, and we can have H3, which is the third header of the whole document, and B stands for being bold, like the texts are bolded, and as we said earlier, UL means we start this as an on-order list, and each LI is basically just entry of the on-order list. So what we can do actually is here, I'll show you, if we copy these things, we copy these things and just basically save them as an HTML file. So for example, we can save them on desktop. And here, we open it, that's how it should look like, rendered by the browser. Okay? So this is just a very simple example of how you can map the HTML code to how it actually looks like. Okay, so here we see here's the first header, okay, and third header, and then here are the bolded part, here are the on-order list. Okay, really simple. That's for HTML. Right? So as we said earlier, for HTML, here all of the tags that it's saying, it's just basically telling the browser, okay, here is an on-order list, and then each of them are the entry of order list, or any other kind of formatting type of information, right? So there are actually some disadvantages of HTML. For example, the first thing is it cannot describe the structure of the content for more general applications. So it's not telling you anything about the structure of the data itself. It's just basically saying how I want it to look like. So between the data, there's no idea of what we learned in the relational model. So this is like for example, this is the book, and these are the information of the book. What are the information? We don't know, because HTML only talks about how the format should look like. So it's actually unsuitable for the exchange of complex documents. So that's why we want to introduce XML, which is the extensible markup language. So XML is also markup, and it's developed to remedy the shortcomings of HTML, as we said earlier. So it actually bridges between the document-oriented view of data. Okay, so a document-oriented view of data implicit in HTML. Like we said before, in HTML, all it cares about is how the document looks like, right? How it should look like when it's being displayed. So a bridge between the document-oriented view of data implicit in HTML and the schema-oriented view of data central to a database management system. So if you think of it this way, when we look at the HTML code, there's no concept of schema being explained at all. Okay? But sometimes it might be useful if we want to include that. So what XML does is actually, it will help you to emphasize the idea of schema in the sense that it can help us to describe the data by saying what are the attributes we have for each relation. Okay? So what exactly is an XML? So XML is a hierarchy of user-defined tags called elements with attributes and data. Okay? So it's very similar to the idea that we can map it to different kind of database we have learned before. Okay? Or we can just directly map it to the relational data model. So here will be an example. Instead of writing in HTML, we write it in XML this time. Okay? So, for example, here I should have done an indentation here, but I didn't. So here we still use the idea of tags. As you can see, we have tags of books, right? So we open a book tab and we finish a book tab. But here, we are not talking about the format at all. We're not talking about how the browser should render it at all. We're just saying how the data should look like. Okay? So we have the book, and then we talk about the book's genre. It is a science genre, and the format is hardcover. So these are, we can say, the attributes of the book element. Okay? So book is the element, genre is the attribute. Okay? So for the book, inside the book, the whole book tag, we can nest it with the author information, right? And the author, inside the author information, we can nest it again, saying the author's first name is Richard, last name is famous. Okay? And his famous book is The Character of Physical Law. Okay, so here we are using the very similar idea of HTML, which is the tags. We have a start a tag, end a tag, but instead of telling the browser how we are going to render it, the format of it, we just basically directly say the structure of the data itself. So here it's really nested. So it's still a little bit different from relational model because we are allowing hierarchy. Okay. So when we show this, which is the concept of hierarchy, it might remind you of another format we have learned before that I kept saying it looks so nested. If you remember, that's the JSON format, right? In JSON format, we can also achieve this kind of nested structure. Let's take a look at JSON format with the exact same data that we want to store. So here's the JSON format, okay? Instead of having tags, here we're just basically using key value pair. So we say the the whole thing is a book, okay? The whole thing with the curly braces. So we say the genre is science, the format is hardcover, and the author first name is this, last name is this, and the title of the book is this, okay? So instead of having different kind of tags to enclose it, we just directly use key value pair. So you might be wondering, so as I said before, JSON has largely replaced XML, okay? So you might be wondering why. Basically, they're the same, right? You're just using different ways of representing it. What's the benefit of JSON, actually? So here I will show you a comparison, but I won't really talk through it because, so I found this in this reference here. So it's comparing different kind of pros and cons between XML and JSON. But one of the most important thing you can remember is just JSON is efficient in different kind of aspects. For example, just think of JSON when we look back on these examples. We have JSON represented this way, however, XML need to represent it that way. So a very shallow, or you can say superficial way of judging them is just basically XML is taking more characters, as you can see, right? The tags take up more characters. So when the data gets larger, JSON actually needs less characters, or you can say less bytes to represent the same idea. Okay, another way is, so who have learned about compilers before? Some of you. So, okay, so basically, whenever we write a piece of code and we send it to the compiler will first start by parsing your code, okay? So it will have a parser, which is actually similar to the database management system we have talked before. It has a parser. So what the parser does, it will go through character by character and try to understand what are the chunk in your code, okay? What is related to what. So a lot of people, they actually done experiment on JSON versus XML in terms of parsing. And they found most of the time, the parser takes less time trying to understand JSON, okay? So we won't get into why, like how it actually works, but you can just remember, for this kind of formatting of representing the exact same data or idea, not only they take less character, but also parsing is faster, okay? And another idea that will make JSON having more advantage, it's all because right now data is so much larger than the past, okay? So another advantage JSON has over XML is when you want to compress things, JSON can have a higher compressing rate. Okay, things actually get smaller when you write things in JSON. All right, so that's for JSON. So those are the three web data formats that I want to talk about. So before we finish, I just want to quickly talk about Markdown language. So some of you have already heard of it. Some of you have not. So far we have only talked about markup in today's lecture. Okay? We say HTML is markup, and XML is markup. So we are not really talking about whether JSON is markup because it doesn't have any kind of tags in there. So JSON is out of the discussion in terms of markup and markdown. So Markdown, it is created by John Gruber in 2004. So they state themselves as being a lightweight markup language with plain text formatting, syntax design. So as I said at the very beginning of the lecture, just don't confuse thinking Markdown is a complete opposite of markup. So actually Markdown is one type of markup. Okay, it's really confusing, but that's actually how the way it is. But so that's the logo of Markdown. So where is Markdown normally appearing? So Markdown is often used to format README files. For example, when you have your GitHub repository, okay, the way you're going to write your README on the repository is actually through Markdown. Okay, so I think when you are trying to commit commit your README file, the README file will have an extension called .md. Okay, so that's Markdown. And also for writing messages in online discussion forums and to create rich text using a plain text editor. So I'm not sure, I haven't seen forums using Markdown before, but why would people want to use Markdown instead of other types of data, like formatting language when we are writing on forums? So the way is actually because of this. So sometimes on the forums you are allowed to do some kind of formatting. For example, you want to bold the text, you want to making different kind of headings. So that's the way it is. You can take a look. On the right-hand side, we have HTML, and on the left-hand side, we have Markdown. So as you can see, the way Markdown represents things is very, okay, maybe weird for you, but if you only start out learning Markdown, it's so much simpler than HTML. Comparing this, for example, we started out by the heading. So in Markdown, the way heading works, it's just you put heading, and then you put a bunch of equal signs underneath it. It doesn't even care about how many equal signs you put. Then it knows, okay, this is the heading of the document. Okay. And then you can have subheading, okay, subheading like this, and then followed by a line of hyphen. Then you can have, for example, if you put 3 of these, then you're saying that's the third heading of this document. And when you want to put paragraphs in HTML, you actually need the P tags. But in here, you just need an extra blank line. Then it knows, okay, this is a whole paragraph. A little bit more, for example, when we want to do bold, then you just put 2 star signs around it. Okay, yeah?
Is the paragraph, is the blank line before or after?
After. Okay.
And what is the real-time application of Markdown language?
What?
And where do we use Markdown language?
Oh, for example, in GitHub, when you want to write the README file, or actually a lot more examples. I didn't give enough. Not sure how many of you write R. Have any of you? You tried R before. Okay, so then who has used IPython notebook before? No? Okay, so let's talk about R. So R actually, I personally use R for profiling data, we can say. We take a data set and we want to understand what's in the data set. So I will use R to plot different kinds of plots, okay? Who have written programs to plot plots before? Okay, we are the only weird ones. Okay, all right, so for R, there's a language called R, okay? So a lot of statistics people use it. It's really statistical friendly when you want to do different kind of statistical analysis, but I think computer science people in general don't like it because it's super slow, okay? So it's user friendly in the sense that you say, okay, I want to fit this linear regression, and it will fit it for you, and it's really easy to use. But what's behind it is all the super slow implementation, okay? But maybe statistical people, they don't care about it because they have really small data set. Okay, so for R, it's really good for doing those things, and you can plot things into plots. So what I will normally do is to have the plots embed in different kinds of documents. Okay, so then I'll talk about, okay, in this plot we identify this, in this plot we identify that. So one of the application Markdown can be used is to integrate it with R. Okay, R is one of the languages you can integrate with. then you can just directly write a Markdown language document and embedding our code. And it generates the whole document, embedding those points. Okay, so that's another application for Markdown. Right? So here, another, a little bit more on Markdown. For example, we have shopping list, and you can just say, okay, the bullet points start like this. We just put the stars. That's it. Okay. So I'll quickly show you how it looks like. I'm not sure about what are the softwares available for writing Markdown in Windows, but if you are using Mac, there is a Markdown tool. For example, we can just say this is, I can say, let's start the document by saying this is the title, okay, and then we just put like that. Then it's done. Okay, on the right-hand side, it knows it's the title of it. And then we can say, let's start the first paragraph. Okay, and then that's the first paragraph of it. Or you can say, I want heading 1, so heading 1. And if you think that looks too similar to the title, you can make it a bit smaller, and then just give it 2 hashtags. Okay. And you can say we can open a list. Then we can say this is the item 1, and we have item 2, item 3. Okay. And if you want to make it a sub entry of it, then you can just say, you just put an indentation. Okay. So one of the funny things of Markdown is, for example, we want to try the number list. You can say this is number 1, and then you can keep going saying this is number 2. But even if you keep putting all of them as 1, it will still render as 2. Okay. So I think it's just helping all the lazy people there. Okay. It will just help you directly, giving you the right order. So that's for Markdown. Okay. Yeah. So actually, right now, a lot of templates are being developed so that, for example, if you're writing latex, I'm not sure how many of you do. Latex is kind of a headache when you want to write things. It's really complicated because it was developed decades ago. So right now, a lot of people are actually using templates for Markdown. You can write things in terms of Markdown, and the renders looking exactly like what you will put lots of effort into latex. Okay, so that's for Markdown. All right, so before we finish, let me just quickly talk about the document type definition, which is what we say about DTD. So the document type definition is basically something that helps us, for example, to check XML. So remember in XML earlier, we have different kinds of elements. We can have book element, we can have author element, right? Title element, all of those things. So how do you know when you write a program it's actually following certain rules, whether it's valid or not? So you can't just put whatever you want. You have to start with a DTD file, so saying these are the allowed elements in my document. Okay, and for each kind of element, maybe the values will have certain kind of rules. Maybe it has to be string, maybe it has to follow certain kind of formats. Okay, so that's what the DTD does. So DTD follows this form. It will have this and a doc type and put the name and tell you the rule of it. So here is an example. Here we have element book list, and then we put parentheses around book, and we put a star after. So who's familiar with regular expression? Oh, good, quite a lot of you. So what does this mean? Element book list consists of what elements?
0 and 1.
0 or 1. Okay, when we have stars, it stands of 0 or 1. So it follows right after the book right here. Okay, so it's this basic state for the book element. It can be 0 or 1. How about the plus sign? 1 or more. Okay. So in the rules, if we have book element followed by a plus sign, it means the book element can be 1 or more. Okay, so here, the third example, we have element book, and it has to contain author, title, I missed an L there, but title, not title, and published. Okay. So published, we have a question mark following it. Anyone knows what it means?
0 and 1.
0 or 1. So we're saying it's optional, okay? But it's supposed to be 0 or 1. Okay, 0 or 1 is more precise. because optional you can interpret it in 0 or more. Okay. So for question mark, it's 0 or 1. Okay, so these are just the rules in regular expression. Okay, so yeah, before we finish, these are just all of the rules that you can look at for regular expression. I will talk a bit more next time so we can see and then why regular expression is useful. Okay? Okay, before you go, just want to quickly tell you for next Monday, that will be the review session and homework 4 will be due. And Tuesday is midterm to part 1 in the evening. Okay, I will announce the classroom soon. And Wednesday, no class. Not this Wednesday, next Wednesday. And then Friday, next Friday will be midterm 2 part 2 in class. Okay? Huh?